Okay, so this is, you know where I got this from? I was listening to the mixed review, and I'm probably going to do some other stuff from that, from the AP online videos. And I was like, wow, this stuff we have not looked at much. So this is wanting you have a piecewise function, and it's a semicircle and a line, and it's between -5 and 4. So they want the limit as x approaches 0 of f of x minus 1. Now that doesn't mean f of x minus f of 1. You can't do it that way. You cannot do f of x minus f of 1. That's not how you do these. This means I want the limit of the function that's translated, that's now f of x minus 1. So we have to remember what we know about translation. So if I were to translate this, write 1, this would be here, and then my circle would be like that. And so if I were asking you what the limit was, you would say that equals 0. So let me erase this. So that equals 0. So that's good, but I also want to show you a more comprehensive way to do that. If you have the limit as x approaches 0 of f of x minus 1, that means that you can take the limit inside the function. That is the limit f of the limit as x goes to 0 of x minus 1. Okay, so it's a composition. This is really a composition. So what is the limit of x minus 1? Well, you can just use standard substitution to take that limit. So that's equal to f of 0 minus 1, or f of -1. And now you can go up here, and you can, instead of looking at it as a transformation, you can just look what you transformed it already. What is f of x minus 1? No limit, just what is it? And sure enough, it equals 0. So that was part A. Now let's look at part B. Okay, part B says the limit as x approaches 0 of f of 2 minus x squared. Well, we can do what we just did. That's f of the limit as x approaches 0 of 2 minus x squared, which is f of, and if we put 0 in here, that's 0, the limit of 2 minus 0, so that would be 2. So then we look at f of 2. Only, we have an issue. F of 2 is discontinuous. Now, that doesn't mean that the limit doesn't exist, because we had transformed it to this discontinuity. So we can't just give up and say, oh, it doesn't exist. The limit doesn't exist. What we have to do is think about this function and where we're coming, because it does exist from the left and it does exist from the right, the limit. So is this one really just talking about one or the other? And it is. Let me get like yellow. Okay. What is the graph of 2 minus x squared? We have to just investigate a little further. Isn't it, here's 2. Isn't it this graph, right? This is y equals 2. So there's the graph of the function. So we're putting that function into this function. Now, if you want to test numbers getting closer and closer here to 2, you would be going 1.99, right? Because you're under 2, okay? Y equals 1.99. And then if you're going here, from this side, aren't you also coming from under? And so it would be 1.99 on that side too, trying to get up to 2. And so since you're coming from under, then you're looking at the limit as x approaches of 2, if you're looking at it that way, from the left. So we are looking at this function right here from the left, so it would equal 3. So, okay, so you would add the from the left. And guys, there's no way to do that except, I'm going to say, after further investigation, right? You have to think about it, okay? All right, now let's do C. It's a really great question. Okay, so C says, find the limit as x approaches 0 of the absolute value of x over x times f of x minus 1. So this is multiplying this times the composition. Now, ordinarily, you can say the limit as x approaches 0 of the absolute value of x over x times the limit as x approaches 0 of f of x minus 1, which we already figured out that this is 0, but what is the limit as x approaches 0 of the absolute value of x over x? I'm so glad this came back around. If you remember what that function looks like, you should. I kept giving you problems with that over and over again. Okay, absolute value of x over x would be a whole here at 1 and a whole here at negative 1, remember? So this limit does not exist. So d and e times 0, can't be. You can't just say d and e either, because, you know, this only works, this property and all the properties only work if the limits of each one exist. So you can't say the limit times the other limit unless they both exist. So we cannot do it using the product rule. Okay, so how do we do it? So what does that mean we do? Well, you can always go back to one-sided. So will this work one-sided, and do you get the same thing? If you do, that's what it equals. So let's look at the limit as x approaches 0 from the left of absolute value of x times f of x minus 1. So that would be, if you break it up, the limit as x approaches 0 from the left of the absolute value of x over x times, and remember this was equal to 0 for both of them, so that would be times 0. So this limit as it approaches 0 is negative 1. So you have negative 1 times 0, which is 0. And then the limit as x approaches 0 from the right of the absolute value of x over x, sorry, that should just be up there, times f of x minus 1, okay, would be breaking it up and just doing, we already know this is 0, so the limit of that is equal to 1, so you have 1 times 0, which equals 0. So because the left-sided limit is equal to the right-sided limit, then we know the limit must be 0. So it doesn't exist if you do it all together, but when you do it separately, you get the same thing. So the limit as x goes to 0 of the absolute value of x over x times f of x minus 1, it's not that it doesn't exist, it equals 0 because the left-sided limit equals 0 and the right-sided limit equals 0. So I just wanted to stop and do those. These were, if you want to know, these are compositions of limits, and we didn't do very many of those in class. So I hope you listened well in case you see something like that on the exam.